Hi everyone. Whenever you read any statement question based on maxima minima, make sure while reading the question you keep three things in mind. First of all, what is given in the question? Second thing, what you have to maximize or minimize. Either they are asking you to maximize or they are asking you to minimize anything. And third thing, what do you have to find or you have to prove? Sometimes they ask you to find some dimensions and sometimes they ask you to prove something. So I'll read the questions and then we'll make all these notes. These are some rough points. This is question number 24th of exercise 6.5. I'm reading the question for you. Show that the right circular cone of least curved surface and given volume has an altitude equals to root 2 times the radius of the base. I have already told you, you have to keep an eye on the word given, that what is given. What do you have to maximize or minimize, and what do we have to show or to prove? So the questions start with show. Now one more thing, if I remove this phrase, I'm just removing this phrase and I'm reading the question again. Show that the right circular cone has an altitude equals to root 2 times the radius of the base, and it makes a sense. It's a complete sentence. It means they are asking you to show that, to prove that altitude, which is usually taken as h for the cone. This is h, this is r, and this is l, which is usually taken as h, is equals to root 2 times the radius. So you have to prove this. Okay, now the phrase which I removed was actually the description about the cone. I'm reading the one which I cancelled out, right? This white underlined part, I'm reading this. Of least curved surface, show that the right circular cone, it means the curved surface area of the cone should be least. So this is, you have to minimize. Least means it is minimum, so you have to minimize this. Um, the curved surface area of cone, curved surface area of cone. And what is given? Look at this word given. What is given? The volume is given. So given is the volume of cone. If you're able to find these three things, half of the question is done, right? So first of all, I'm writing what is given in the question. Given is volume, which is 1 by 3 pi r square h. Very, very important. We are going to use it in derivative. Now what do we have to differentiate? The function which you have to maximize or minimize is always differentiated. What do we have to maximize? Curved surface area. So let's see, denotes the curved surface area. The curved surface area is pi rl. This is equation number 2. You have to differentiate this equation. Now the procedure for the maxima or minima. First of all, you will identify the function. So function, you will identify, you will do the derivative of that function, you will equate it equals to 0, you find the critical points. Whenever you put the first derivative equals to 0, from there you get the proving part, or if you have to find anything, you will get that part. Then you will do the second derivative. If your second derivative is less than 0, you will get the maxima. If the second derivative is greater than 0, you will get a minima. In this question, you have to minimize the curved surface area. It means your second derivative should be greater than 0. So this is the procedure which we follow in all the questions. And this proving part is very, very important. The moment you put the first derivative equals to 0, you get the proving part. Sometimes you do not get the proving part straight away, so we use what is given in the question. So we can use equation number 1 to prove what is asked in the question. All right, let's start with the question now. Curved surface area, it is having two variables. It is having r also, l also. You have to represent this in one variable. You have to rewrite in, you have to do something so that it is written in one variable. Variable means either it should be written in terms of r or l. Also, whenever you have cone, you can use this knowledge of yours that l square equals to r square plus h square. Let this be equation number 3. Now you have identified that you have to differentiate C. So I'm starting with C. Now this C is having R also, L also. I can get rid of L using equation number 3. So what is L? L is under root of R square plus H square. But now the thing is, I have removed L, but I am having H now. Right? So you have to remove H. See, if I'm writing this expression, I should write only in terms of R, or only in terms of L, or only in terms of H, anything. Also, whenever you have to differentiate any function which has a root, you can do squaring both sides, because I do not want to apply the derivative of a root function, because then you have to apply product rule, chain rule, and it will be little lengthier. So you can rewrite in this manner. Now what is H over here? You can write C square as C1. Let this be C1. So H square, I have not used the given part till now. From given equation, from equation number 1, you can use the value of H. What is H over here? H will be, what is H? I'm rewriting H over here. H is equals to 3V upon pi R square. So you can use H over here. So R square. So H square will be 9V square upon pi square R raised to the power 4. You have to simplify, and then we are going to differentiate that. So I'm taking the LCM over here. My LCM is pi square R raised to the power 4. I'll get pi square R raised to the power 6 plus 9V square. Right? Cancel out. Pi square and pi square will get cancelled. R square will cancel this, and you're left with R square now. Rewriting the function, C1 is equals to pi square. It will be R raised to the power 4 plus 9V square divided by R square. Now this C1, this curved surface area, is expressed in terms of one variable, that is R. So I have fulfilled that criteria over here. It should be expressed in one variable, and it is done. So let me name this equation. Let this equation be equation number 4. I am differentiating both sides with respects to R, because R is the only variable now, V is constant. So dC1 upon dR, pi square is constant as it is. Derivative of R raised to the power 4 will be 4R cube plus 9V square as it is. Derivative of 1 upon R square means the derivative of R raised to the power minus 2. Apply power rule over here. This is minus 2 upon R cube. Rewriting this, that is 4 pi square R raised to the power 3 minus 18 V square divided by R cube. For any maxima minima question, as I mentioned in the beginning, for maxima or minima, you put the first derivative equals to 0. So you are going to put equate it equals to 0, which I'm going to do now. So I'm putting it equals to 0 means 4 pi R cube is equals to 18 V square divided by R cube. Cross multiply. 4 square. 4 pi square R raised to the power 6 is equals to 18 V square. I told you in the beginning, the moment you put the first derivative equals to 0, you get the proving part. What do we have to prove in the question? You have to prove that H is equals to root 2R. Are you getting the proving part over here? No, rather we are getting this equation. So here comes the use of the given. So we can use what is given. So I'm using equation number 1. Let this be equation 5. So I'm using equation 1. I'm using the value of V, and I'm putting in right hand side. So 4 pi square R raised to the power 6 as it is, 18 as it is. The value of V square, it will be 1 upon 9 pi square R raised to the power 4 H square. Okay, let's cancel out. Pi square and pi square will be cancelled. You are left with R square. 9 2s are 18 and 2 over here. So what I am left with? I am left with 2 R square is equals to H square. H is equals to plus minus root 2R, which is negative is not possible. So the proving is done that H is equals to root 2R. So your proving part is done. You have to minimize. So the question is not done. You have to minimize the curved surface area. It means you will do the double derivative. So I am differentiating this again. I am doing D2C 1 upon dr square. I'm differentiating equation number, actually this equation. So I'm differentiating this over here. All right, so I'm rewriting this. This one is differentiated, right? So 4 pi square is constant as it is. Derivative of r cube will be 3r square. Now minus 18v square as it is. Derivative of r raised to the power minus 3, which is minus 3 into r raised to the power minus 4, means you are left with this. So this is 12 pi square r square plus 54 v square divided by r raised to the power 4. You can see that everything is square. It's a square over here, square here, square here, square here, means it has to be positive. It's not the thing that you have to put any value and then you have to check. You can do that also, but it is all positive because it is all square. It means the curve surface area is minimum. They have used the word least, so make sure you use the word least. It is least when, what is the critical point? The point is when h is equals to root 2 times the radius of the cone. So that's a question. So first thing, I'm just do a recap. Make sure you write these 3 points. If you're done with these 3 points in the beginning, half of the problem is solved. Moreover, you always keep an eye that what is given in the question, because given is used in the proving part also. Also, you have to minimize the curved surface area. It means this should be differentiated. It has 2 variables, so you have to get rid of the variable, do the first derivative, equate it equals to 0. You will get some equation from there. If you're not getting the proving part, use the given part, then do the double derivative. If the double derivative is greater than 0, it is least. That's all for this question. Thank you very much. I will be doing some more questions with you. Bye bye. Thank you.